Hey guys, so we're still in section 4.3, it's page 366, and we had just taken some time to do some of the basic examples of coming up with the equation of a line, given the slope and the point. This page I have more of those, but now these are going to get a little bit trickier. So let's start with A. Why don't you go ahead and just pause the video. Go ahead and use whichever technique you'd like. You've got the point, you've got the slope, and you need to have this in slope-intercept form. Hit play when you're ready to see the solution. Okay, so for this one, I will use the point-slope form, but if you use the other form, that's totally fine. So I'll go ahead and I'll plug everything in as shown. And so now I need to flip all my signs. So this will be y plus 2 equals 1/3 x plus 1/3 times x plus 3. So now I have to get this into slope-intercept form. So first things first, I've got to distribute. So this will be y plus 2 equals 1/3, gosh, I cannot write, x plus 1. And then all I can do to finish this is to subtract 2 from each side. So I get y equals 1/3 x minus 1. And that's all that one's asking for. Okay, so moving on to the next one. If you haven't tried it yet, pause, hit play when you're ready. So for this one, I'll use y equals mx plus b. And so first I'll plug in the point. And I'll multiply the 5 and the negative 1 together. So this is going to be 5 plus b. Subtract the 5 from each side, and you get b equals negative 2. Now, from here, you have to be a little bit careful. So first you might restate this in, the slope-intercept form, negative 5x minus 2. But the thing that tends to get people on these types of problems is they forget to reread what the final answer needs to be in. So we need standard form. So always double check and then just see if you have to manipulate your problem one more step. So I get 5x plus y equals negative 2. If you find that you're always missing this step, I would probably consider just highlighting it, like doing something really clear and obvious in hopes that you don't forget. Okay, so we've got one more example, still standard form. I've got the point, I've got the slope. Hit play when you're ready to see the solution. So for this one, I'm just going back and forth between the two techniques. Oops, this is minus negative 1, or x of 1. Okay, so let me plug everything in. So this will really be y minus negative 2 equals 1/2 times x minus negative 1. So that'll be y plus 2 equals 1/2 times x plus 1. And now I distribute. So I get y plus 2 equals 1/2 x plus 1/2. Now you might be thinking to yourself, oh God, I got this fraction and now I got to deal with common denominators and this and the other thing. But here's a little trick. You don't have to deal with the fractions if you don't want to. What you can do is you can just go ahead and clear them out at this step. So what's the LCD that I'd have to multiply everything by? So the LCD of all of these fractions would be 2. So if I multiply everything by 2 just to clear out the denominators, so look what will end up happening. The 2's will cancel out here and here. So in the end, I'm left with 2y plus 4 equals x plus 1. And I would much rather just now go ahead and find the standard form of this and press forward with the problem than having to deal with the fractions. So that's something that you can do after you distribute and kind of get that all set up. Okay. And then I can finish getting this into standard form. So I get negative x plus 2y equals negative 3. And that's it. We're good to go. Okay, so now what we're going to do is we're going to talk about parallel and perpendicular lines. And I have kind of a strange exercise, but I think it will help you kind of get the idea behind parallel and perpendicular lines. So what makes two lines parallel is that they have the same slope. Okay, so what I want to do here is I want to come up with the equation of any line that is parallel to the one that I've given you. So starting here with y equals 2x plus 4. So now we really have to think about what does it mean to be parallel. Parallel lines have the same slope. So notice with this example, what is my slope? The slope here is 2. So I'm going to show you just a few examples of some equations that would be parallel to y equals 2x plus 4. So here's one. Y equals 2x plus 1. Here's another one. Y equals 2x minus 7. Here's another one. Y equals 2x plus 74. So really, as long as you have the slope of 2, no matter what you do, the line is going to be parallel. All you need is that same slope. So as long as you have something like y equals 2x plus anything you want, you are going to have a parallel line to 2x plus 4. So I want you to think about that for B and C, and think a little bit carefully about C. Hit play when you are ready to see the solutions. So for B, so the slope here is negative 1/3. So it doesn't matter what equation you came up with. Here's like two of them, y equals negative 1/3 x plus 7, or y equals negative 1/3 x plus 13. It could really be y equals negative 1/3 x plus really any number that you want, and you'll be good to go. So again, it's just learning to pick out and get in your brain what makes something parallel. Now be careful with C though. What type of line is this? And don't say a straight one. Everybody always says it's a straight line, and I'm always like, oh my god, all lines are straight. Yes, I know. It's a specific type of straight line, right? So if you think about it, oops, moving everything around. So x equals 5. So here's 1, 2, 3, 4, 5. So it would be one of these, right? These vertical lines. So I just need the equation in this case of another vertical line. So something like x equals 2 or x equals 9. Totally doesn't matter. It could be x equals any number, and it will be parallel to x equals 5. So parallel, so for vertical and horizontal lines, you just have to be a little careful and watch out for them. Okay, so now what I want to do is I want to talk to you about how do we find the equation of a line that is parallel to another line. So the first thing that you'd have to do is you have to determine the slope of the given line. And then the second thing that you have to determine is determine the point you need. This is generally given. And after you have those two pieces of information, then you can plug this into your y equals mx plus b, or y minus y1 equals m times x minus x1 form, and find the line. So these are kind of the general steps. So in general, you always need a point and a slope to write any line. All we're doing here is now we're making it just slightly harder to find the slope. So looking here at example 8, I want to get a bunch of lines in slope-intercept form that are parallel to the given line and goes through the desired point. So starting with A here, so looking at my 2x, so the m that I have and need will be what? It'll be 2. So now look what I've got. I've got my slope, I've got my point. So now I can use either form of the line. I'll use the mx plus b form now. And so this will be, I can plug into this information. So this will be 5 equals 2 times 1 plus b. So this will be 5 equals 2 plus b. Subtract off the 2. I get b equals 3. And I need to put this in slope-intercept form. So now I use y equals 2x plus 3. So you have an extra step of having to pick out the slope, but then otherwise, once you find that, the rest just goes forward as kind of what we've been doing so far. So what I want you to do is try B and C, and then hit play when you're ready to see the solution. Okay, so for B, I will use the point slope form. So the slope that I need here will be negative 2/3, so I'll just note that up there. So now I can plug in my information. So this is y minus 3 equals negative 2/3 times x minus 6. So now I've got to distribute that negative 2/3. So this is y minus 3 equals negative 2/3 x plus 4. Now a pro tip here. If doing this, having to multiply this fraction out, if that kind of bugs you, then just consider doing that calculation somewhere on the side. You know you've got to do negative 2/3 times 6. So if you have to write it on the side, just write it on the side. Remember, this is really over an invisible 1, so this would equal negative, this was negative 6. So this would equal positive 12 over 3, so that would equal 4, which is exactly what I got over here. So just a trick there for you. Okay, so now I've got to get this in slope-intercept form, so I'll just go ahead and add 3 to each side, so my final answer will be negative 2/3 x plus 7. And now for this last one, so I'll use again my y equals mx plus b form. I'm just going back and forth. So the slope that I need, I just want to note that I need the m equals 3. So I've got my point, I've got my slope. So now I can plug all this information in. So I get 4 equals 3 times 1 plus b. So 4 equals 3 plus b. Subtract 3 from each side. I get my b equals 1. So then my final equation will be 3x plus 1. Okay, so that seems actually like a good place to pause because this video is going to get a little bit long. So in the next video, we'll talk about the next type of lines, working with perpendicular lines. So I'll see you then.